Okay, I just want to do a quick video on the review of the Bohr-Rutherford model. I'm going to use magnetics to show you, especially when we get into chemical reactions and things like that. So really beneficial for you to see that. So quickly, we're just going to look at the three subatomic particles, of main ones, although there are many more. But the yellow magnets are going to represent what are known as protons. The green magnets are going to be representing neutrons. And the red magnets are going to represent electrons. Okay? So when the discovery of the Bohr-Rutherford model, I've written some information in the content about this pretty spectacular discovery. We're looking at a single atom. Okay? A single atom. We could start with something as simple as hydrogen, let's say. But when we're looking at these atoms, we are, through research, we know a few things about this basic atomic structure. So the center is where we're going to find our protons and neutrons. We call this a nucleus. So the nucleus is where we're going to find our protons and our neutrons. Okay, so that's protons and neutrons. Okay. Orbiting around this densely packed nucleus is our electrons. And for this course, I'm just going to show the three shells. So we have the first shell. And we know that that can hold a maximum of 2 electrons. We have the second shell. And that can hold 8 electrons. Kind of makes sense. It's further away. It's a bigger shell. Okay. And then the last one is our third shell. There is more shells the bigger the atoms are. Our third shell, and for simplicity we're just going to say that this is going to hold 8 electrons. It does actually hold more, but we're okay with saying electrons. So this model is still accepted and we're going to use it. So these are, it's really kind of, if you look at this model, it's huge, gigantic on this board. We're talking about a extremely small particle. In fact, really hard for us to even imagine how small this is and how little mass it has. Okay. So going through an example, we can look at something like, as I mentioned earlier, hydrogen. So it is, you'll see me state this quite a bit through when we're looking at our, going through our content. It is the protons that determine the element. And from your previous grades, we know that the elements all make up matter. Okay? Matter is all ultimately has an element in it. They can typically find them chemically combined to form molecules, but it all comes down to the basic ingredients of all matter. There's going to be elements involved with that. Okay? So in the case of hydrogen, the word hydrogen, symbol H from our periodic table. We'll be going into more detail of the periodic table later on. I just want us to feel quite comfortable with the Bohr-Rutherford representation of these atoms. So an atom of hydrogen And there's a couple things we want to do that you're going to be working with in PhET, the simulation, is that we want it to be neutral and we also want it to be stable. So I want to talk about, we're going to make this atom neutral. Okay. Oops, they mixed cursive in there. Okay, for determining if something's neutral, we need to first look at the charges that our subatomic particles can have. Okay? So recall that our yellow magnet is a proton, and it is positively charged. Okay? A neutron has no charge. An electron is negatively charged. Okay. So when we're looking, I'm just going to pull this off for a minute because I want to, or push this off to the side a little bit here. That when we're looking, so there's charge and that's about neutral. Okay. When we look at the mass of the actual atom, it is a proton and neutron that are contributing the major amount of mass to the atom. And you'll hear me call these heavy particles. Okay? They are heavy particles, and in your notes you're going to make some notes that these are the ones that are contributing to the mass. The electron is very, very, very light. Practically no mass when you start comparing about the protons and the neutrons. So we can see that the majority of the mass is found in our nucleus, which we're going to do some examples over here. Okay, so if I'm looking at hydrogen, hydrogen has a proton found in its nucleus, and it has one electron in its shell, first shell, and because the proton's positively charged and the neutron's negatively charged, our net charge is zero. There's no, charge. If I was to take that electron away, this atom would now be positively charged. Okay? But when we add that electron, we got one proton, one electron, and they cancel each other out. Okay, does the hydrogen have any neutrons? Well, some of them do, but the most common one just has one proton and one electron. Okay. There are, again, we're going into this a little more detail. There are hydrogen atoms that have also a neutron, and that's when we talk about isotopes. Now, why is this still hydrogen? Because it is the protons that determine the element. It still has one proton, so that makes it hydrogen. Okay? It is neutral because it has one electron and one proton. We've added a neutron, and this makes it still a proton, but a different, still a hydrogen, but a different type of hydrogen, and we call those isotopes. Okay? So that's like an introduction into the protons, neutrons, and electrons. Not an introduction, this is a really review. I am showing the most common form of hydrogen is one proton and one electron. So I am showing this neutral, and this is the most common form. Okay. When we look at how, we don't always draw pictures, we typically go to math or numbers, that I could represent this by this hydrogen. So hydrogen has one proton in this model I'm showing you here. And what do we call that? We call hydrogen, we call that an atomic number. Okay. So in the case of hydrogen, the atomic number equals 1. That means it has one proton. Because it's neutral, so it has one electron. Okay? So a neutral hydrogen will have one electron. Okay? So the atomic number is telling us our number of protons, and if it's neutral, we know it's going to have one electron. Okay? So when I look at now, how do I figure out the mass of this? How do I figure out how many neutrons, how many neutrons are found in this atom? We go to something called atomic mass, and again, we're getting into periodic table stuff, which we're going to be spending some more time. When I look at the atomic mass of hydrogen, I find it equals approximately 1 atomic mass unit. The atomic mass unit, AMU, is a little bit of older school. They actually have simplified that to just a U. Okay, it's a measurement. It's quite a small amount of mass. But we see that hydrogen has approximately a mass of 1 atomic mass unit. Okay. So the atomic mass is saying it's 1 atomic mass unit. I talked about protons and neutrons being the heavy particles. If you go back to this part, we know that a proton has approximately 1 atomic mass unit. We know that a neutron has approximately 1 atomic mass unit. They are our heavy particles. And the electron is a very, very small part of that. So if I know that hydrogen has 1 atomic mass unit, I can use some math to actually figure this out. How many neutrons I might find in this element. So I'm going to just remove this part here, go up here on the side here, clean up my space here. And again, this may be review from some previous grades. If not, it's a good refresher. So to determine the number of neutrons, we take the atomic mass, and we subtract the atomic number. And again, guys, this is all in D2L content. I'm just trying to connect it for you. Okay? Atomic mass minus atomic number. So let's do the example of hydrogen. If I look at my periodic table, I see it's got a mass of, it actually shows a mass 1.01 atomic mass units. And so that's what I got that from the periodic table. The atomic number, if I look on my periodic table, I see it's got an atomic number of 1. So this equals 0. So this is actually the most abundant way we find hydrogen, it's typically with no neutrons. Now when you're working with FET, you'll find that you can still put neutrons in this, it's still stable, but please note that this is still hydrogen, it's just an isotope. It's got a different number of neutrons, therefore it has a different mass. So what would be the mass of this hydrogen? Well, this hydrogen would be, its atomic mass would be about 2 atomic mass units, because a neutron has 1 atomic mass unit and a proton has an atomic mass unit. So its atomic, whoops, I should have wrote that out. Its atomic mass would equal 2. Okay, hopefully that'll help you out with connecting some of that material in the content section. And I will be referring to, well, these magnets I'll be referring to quite a bit, because when we look at these electrons, they're the ones that are involved when we chemically react things and make, explode things and have a lot of fun. Okay.